Hi there, this is Kevin Patton with a brief audio introduction to episode number 53 of the A&P Professor podcast, also known as TAPP Radio, an audio roundup and trail ride for teachers of human anatomy and physiology. Coming up in the full episode number 53, we're going to do some updates, and one of those updates is on the shape of the heart and how that relates to what we do in our life, especially related to the kind of activity that we have. And then another update is talking about exosomes, which are little organelles that we don't often talk about in the A&P course, and their possible role in the spread of cancer. And then the featured topic is going to be ways that we can amplify learning in our course. So that's all in the upcoming episode number 53. The free distribution of this podcast is sponsored by the Master of Science in Human Anatomy and Physiology Instruction, the Happy Degree. I'm on the faculty of this program, so I know the incredible value it is for A&P teachers. Are you looking to power up your game in teaching A&P? When's the last time you had a thorough review of all the core concepts of both anatomy and physiology? Or comprehensive training in contemporary teaching practice? Check out this online graduate program at nycc.edu/happy, that's HAPI, or click the link in the show notes or episode page. It's time for word dissections, and I have 5 terms that we're going to dissect. 3 of the 5 are terms that are probably going to be very familiar with you. And all of the parts that we're going to end up with after we do our dissection are all word parts that I'm sure you're very familiar with. So let's get going. And the first one is metastasis. And that's a term that we use occasionally in A&P teaching, right? When we're talking about how things can go wrong in a normal tissue, both in terms of structure and function. And so metastasis is when a cancerous tumor starts a new colony somewhere else, or at least that's a way to describe it. So we're going to have additional cancers that move beyond that original primary cancer or tumor. So breaking it apart, we start with meta, which we see a lot in terms used in A&P teaching, and that can be translated differently depending on how it's used, upon its context. It's like a lot of words in English that have multiple different meanings and sometimes different nuances depending on how you're using it. So meta is one of those word parts, and it can mean beyond, or it can be translated as among, or sometimes it's translated as after. And there's a few other variations as well. And then the next part of the word, stase, comes from the word stat. It's an alternate form of the word stat, and stat means stand. And then the is that comes after that means a state. So when we put those last 2 word parts together, stat and is, it becomes stasis, and that we can translate as the word standing. So it's the state of stand, right? I mean, it's the condition in which we stand. When we put that all together with the meta part, now we have standing beyond or standing after. But it's often translated as changing, which, yeah, okay, I get that, because you're standing after the state you were in before. You've shifted to a different state. But with metastasis, at least, when I'm thinking of what the word parts mean, I'm thinking of, here's the tumor, and oh, look, there it is over there now. And so it's standing beyond, right? It's now, whoops, I thought it was there, now it's here. And really, it's a second one. It's a secondary tumor in that second place. So that's metastasis, is the process of that movement of establishing a secondary tumor. The next term that we're going to dissect is extracellular vesicle, and in the literature I noticed that it's very often abbreviated capital E, capital V, and for extracellular vesicle. That makes sense. Breaking this apart, we have 2 parts to that term, and extracellular is the first part, and extra means outside. Then the next part, cell, it literally means storeroom. But of course, here we know that it means a cell of the body, a biological cell. And then the UL part means little. So cellule means little cell. And then the AR ending means relating to. So if we put all those word parts together, we could translate that phrase made up of word parts as outside the little cells. So extracellular, outside the cells, or relating to something outside the cells. Yeah, okay, that makes sense. And then vesicle, the second part, and vesicle is a term we use a lot in A&P teaching, right? And if we look at the first part of that word ves, or vesic, it comes from a Latin word vesica, which means bladder. So, and that implies that it's going to be fluid-filled. It's going to be soft-sided and fluid-filled, expandable. And then the CLE ending means little. So we put that all together, and it's a little bladder, a little fluid-filled, soft-sided sac. Of course, that makes sense too. So we put the two words together to make extracellular vesicle. We're looking at a soft-sided, fluid-filled sac that's outside the cell. Okay, that makes sense. Now let's move on to our third term, which is exosome. And exo means outside, just like extra does, and some means body. So it's a body that's outside. Now the implication here is that it's outside the cell, because we're looking at an organelle that has been formed by the cell and sort of pushed out of the cell, and that exosome has stuff in it that used to be in that originating cell. And now it's going to move into the extracellular space, and it's going to become an extracellular vesicle. So an exosome is a kind of extracellular vesicle, and it contains substances that are going to move through the extracellular environment, the extracellular matrix, and probably end up at and possibly merging into another cell, where those substances that were in the vesicle are going to have some effect in that second cell. So that's exosome. Now, another kind of extracellular vesicle is our fourth term that we're going to dissect, and that is oncosome. And that first word part, as I'm sure you know, is onco, which means, well, literally means a swelling or a mass, but the implication here is a tumor, and we usually use it in the context of a malignant tumor or cancer. So we could translate the word part onco as meaning cancer or relating to cancer in some way. And then some, well, we've seen that already a couple times just in the last few minutes, and that means body. So literally means a cancer body. But it is another kind of extracellular vesicle, and it contains substances that came from a malignant tumor cell. And yeah, just like the exosomes, they could end up moving to another cell and having some kind of impact on that cell. And it's probably not going to be a good impact because it's coming from a source that's not really the kind of cell we want to have in our body, right? It's a cell that's not normal. And so it's probably going to contain some substances that are going to enhance the viability of the tumor and possibly at the expense, either directly or indirectly, of the normal cells in that little microenvironment in whatever tissue that we're looking at. Okay, so we've covered four terms so far: metastasis, extracellular vesicle, exosome, and oncosome. And the last term, and by the way, all these terms are going to show up in the full episode. So that's why we're kind of reviewing them here, and of course just really practicing our word dissection skills. The last term is transcytosis. And so the first word part, trans, is a commonly used one in scientific terminology, and it means across. Then the next part, cyte, C-Y-T, means cell. And then the osis part at the end means a process. It can mean a condition of or state of as well. Transcytosis, then, is a process of something going across a cell. And the way it's used in most contexts in biology is it's describing a process where a cell takes up an extracellular vesicle, moves it inside of that cell, and transports it, using the cytoskeleton, of course, transports it across the cell, and then pushes it out the other side. And so if you have a membrane made up of cells, like an endothelial membrane, for example, then a vesicle could approach the endothelial cell. It could enter the endothelial cell and come out the other side. Now, it's on the other side of that wall that was formed by the endothelial cells forming an endothelial membrane. So we have transcytosis. And before that we had oncosome, before that we had exosome, before that we had extracellular vesicle, and before that we had metastasis. That's enough for today, right? Marketing support for this podcast is sponsored by HAPS, the Human Anatomy and Physiology Society, promoting excellence in the teaching of human anatomy and physiology for over 30 years. Go visit HAPS at theapprofessor.org/HAPS. That's HAPS. Last week, I was on a call with a listener from my office, and if I'm ever talking to any of you on the phone for more than about a minute, I'm going to pull the Swiffer out and start dusting my bookshelves. I have lots of bookshelves in my office with lots of books on them, all of which gather what seems to be more than their fair share of dust. So I'd just hung up with my caller, and I was finishing up dusting that last shelf in the bookcase when I noticed a book that I'd not looked at in a long time. It's called Prime Mover, A Natural History of Muscle, and it's written by Stephen Vogel. And I smiled because, even though it was 10 years ago, I started remembering how much I liked the book and how much it helped me with my teaching of anatomy and physiology. Now, as you can tell from the title, it's all about muscle. And muscle is an important character in the story we tell our students about the human body, right? The whole first half of the book or so tells that story, but taking quite a bit more time and care with it than we typically do in our A&P course. So that part of the book was really helpful to me to see how this guy, Stephen Vogel, who'd done a lot of research on muscles and spent a lot of time working out a good way to tell the story of muscle, laid everything out for the reader. Now, I had a vague recollection that I'd underlined a bunch of passages and dog-eared a bunch of pages. But when I thumbed through the book the other day, it was like totally unmarked. If I wanted to sell it, I'd get a good price for it. And then I remembered that I'd stuffed a bunch of note cards in the book and jotted notes as I read it, instead of marking up the book directly. So the fact that I took notes tells you that I found it valuable. But not just the first part of the book. That really was a long and interesting story about the structure and function of muscle. The back half of the book, which focused a lot on how we use our muscles for, a variety of different tasks that humans do, well, that was also interesting and useful. It even talked about how the domestication of certain animals has a lot to do with how we humans use our muscles. Besides giving me an opportunity to refresh my learning of muscles, it gave me things that I could bring into my own telling of the story. It also gave me a lot of background and context that I may not bring into my own course, but it's there for me in case I do need it. And even if I never really need it, it's still an enjoyment for me. And it feeds into and supports that joy and amazement regarding the structure and function of the body that informs the way that I teach. Regular listeners know that I'm all about approaching teaching as a form of storytelling. And Stephen Vogel tells a great story about muscle. And reading his version of the story helps improve my version of the story. If you want to find out more, or perhaps use our affiliate link to buy a copy, boy, wouldn't that be great? Just go to the show notes or the episode page, or check it out at theapprofessor.org/book club. A searchable transcript and a captioned audiogram of this preview episode are funded by AAA, the American Association for Anatomy, at anatomy.org. Well, this is Kevin Patton signing off for now and reminding you to keep your questions and comments coming. Oh yeah, and also those book club recommendations. I'm still giving away Amazon gift certificates for anybody that contributes a book club recommendation to the podcast. And also, there's still room in that group of 5 for a drawing for the Amazon HD10 Kindle tablet device. So, yeah, you want to jump on that one. And you can do that by calling the podcast hotline right now at 1-833-LION-DEN. That's 1-833-546-6336. Or visit us at theapprofessor.org. Hey, and why not take just a moment this week to share the AP Professor podcast with a colleague? I'll see you down the road.